so I'll have to do that.
Can we do a problem with the Newman projection, like the fifth diagrams?
Sure. Couple of points about these kinds of problems. Usually I'll give you a name and I'll say which one is the most stable conformation of, and then I'll give you a name. It would behoove you to actually make sure that the structure that's on here is the structure for that name. Because you may have structures on there that aren't that compound. And so if they're not that compound, they can't be correct. Right? That's a little trick that I learned from other people who write standardized exams. So you have to first of all just make sure all the compounds are the correct ones. But let's say, for instance, so if I gave you these, I could ask you to order them from most to least stable. So if I gave you these first three, A, B, and C, what would be the ranking of those? What would be most stable down to least stable? If you were going to look at that. Does anybody have a most stable? Any other letters you want to throw out? What? I had a couple B's. What else? A? C's? So when we do this, how did we do this? Our first test is to do what? Let's count the number of Gauss interactions. So in this case, we've got one Gauss interaction, we've got two Gauss interactions, over here we've got 1, 2, 3, over here we've got 1, 2, 3, so 2 beats 3, so A would be the most stable, based on the number of Gauss interactions. Then B and C are tied, so now we have to look at the individual Gauss interactions. And so, of those two, which one do you think would be more stable, B or C? B, and the reason for that is the two biggest groups are on the outside of kind of that 4-group collection. So if you wanted to, you could actually count up the number of interactions. But in this case, we can do that. So we've got, starting on the left, we've got an ethyl-methyl interaction. We've got a methyl interaction, and over here we've got an ethyl-methyl interaction on the end. For C, starting down here on the left, we've got ethyl, we've got ethyl-methyl, and we've got, wait, I didn't start down long enough. We got methyl-ethyl. So we got a methyl, methyl. So now we can do is now we can cancel them out. So I see an ethyl-methyl. So now it boils down to a methyl-methyl versus an ethyl-ethyl, and methyl-methyl wins. If you don't like the idea that the big groups are at the end, or kind of at the end of the four group chain. So B would be next most stable, and then C would be the least. So like I said, if you see this, the first thing you want to do is just make sure that they're all the same molecule, and that they're the molecule I'm being asked about, that I'm asking you for. Then if you were doing gauche, or if you were doing eclipsed conformations, what am I looking for there? The eclipsing interactions are bad, so we count up the number of eclipsing interactions, and then we look at the individual sizes. So here I would have two methyl. Well, the methyl groups and the ethyl groups are going to stay the same. And I'm going to just write the ET. I will not do that on this exam. I don't think there's any ET or iProbe for the different groups. I think I completely write them out. I can't say that for the final next semester, but there's always a little key as to what ethyl is, what ET is. So then what I would do to form my eclipsed is bring my methyl group back, so then that puts an H there, that puts an ethyl group there, and now I just go ahead and I rotate around. So I rotate clockwise, and then I'm going to rotate again. So the ethyl group will be there, the methyl group will be there. So now I've got D, E, and F. Now, you won't have to do this on the exam. They'll already be there. So I could have this as an ordering question. I could have like 5 choices in terms of what's the ranking from most to least stable. I could have this as a problem where I say what's the most stable, what's the least stable, etc.
Problems only ever have like hydrogen and methyl groups attached to them.
I could probably put an isopropyl group there, but there is a limit as to how many groups I can attach to this, because if there's too many groups there, our rules don't necessarily follow. We have a hard time. This is relatively simple, this first one, in terms of you could actually identify it, but you could get to a point where, like what's, if you had a methyl, if you had a methyl ethyl versus a methyl isopropyl, I guess you would call the methyl isopropyl worse. But there are points where we can break this down. There are older exams where I said I accepted all the answers because of the problem I made. I had to use the computer to figure out what the order was. So if I have to do that, everybody gets credit for their order. So if there is a point where this breaks down. So that's why I usually use methyls and ethyls. So of these ones, which one is the most stable? I hear D's. Do we agree? So D would be the least stable because it only has what? One eclipsing interaction. And over here we've got each of these two molecules has two eclipsing interactions. But wait. D and F have one eclipsing interaction each. So methyl-methyl versus ethyl-ethyl. So D would be more stable than F, and then the one that has two interactions, E would be the least stable. So again, for staggered, it's Gaussian interactions. For eclipsing, it's eclipsing interactions, Mary.
So you're saying that if you asked us for a certain molecule and one of a few of these weren't that,
then I can't ask you to order it.
okay.
So there wouldn't be an ordering question where one of the molecules doesn't count. But I could say, of these, which one is the most stable? And I only get, for this exam, I only have a maximum of 5 answers. You know from the lab I have the capability to go to 10 multiple choice answers. But many of the questions that were written long before I had that capability. So there's only 5 choices that you get. So in this case, if I did this, I would have 5 choices to choose from. And none of the above is used sparingly, but it may show up. So you might have none of the above.
So